Last set of problems, everyone. Okay, so now that we've already done the exponential equations, it's now time to move on to the logarithmic equations. Okay, so first, we know already what's a log. A log is a translation of an exponential equation. For example, if you have 2 raised to what power gives you 16, you can just take the log to give you the exponent, right? Because the inverse of an exponent is called a logarithm, right? Say logs. So log, then this should be, right, the base. Log base 2 of 16 equals what? Equals 4, right? And that's the value of x. Because remember, when you take logarithms, it'll always give you the value of the exponent. That's how you take logs of numbers, based on the given basis that you see down there, which is log base 2. If you see log with no base, that's already base 10. It's already implied. But on here, that's the answer. And for example, if you have 10 cubed, that gives you 1,000. 1,000, if we translate that to log, this log that you see right over here is base 10. Although hindi mo siya makita. So log base 10 of 1,000 equals 3. Right? So that's how you play the game of logarithms. Anyway, let's get to the game. So we have here log of n minus 1 is equivalent to log of 3n minus 23. What do you think is the value in this situation? The value of n is very easy for you to solve here. Do you know what do you do here? Look, since all the logarithmic bases are the same and they're equivalent with each other, they can be reduced. Like for example, do you remember I told you 10 raised to the log base 3 n of minus 23 is equivalent to log base n of 1. Right? That's the answer, right? So you need to raise that to the 10th power to get rid of the logs in both situations. And when you do that, you're now back to basic algebra 101. So n minus 1 is equivalent to 3n minus 23. Now what do you do to those logs? Now all you have to do is to shift the variable. So the n moves to the other side, making it positive 23 minus 1. And that's equivalent to 3n minus n. 22 is equivalent to 2n. Divide both sides by 2. N equals 11. But wait, we're still not yet done. Let's verify if this were true. Because 11 minus 1 equals 10. And log base 10 of 10 is just 10. It's just 10, right? Because 10 raised to what power gives you 10? That's 1, right? On the other hand, 3 times 10 equals 3 times 11 is 33. 33 minus 23 is 10. Log base 10 of 10 is 1. Very easy, right? Next, number 7. In this one, since all the logs are the same, let me repeat the instruction. Log, no base to specified, right? But the answer is y squared plus 5y plus 15 is equivalent to log of 8y minus 25. How do you solve for the variable of y? Since all the logs are the same, goodbye logs. Now we can go back to algebra. So do I remember just what I told you here? You have y squared plus 5y plus 15, right? Is equivalent to 8y minus 25. So now we have a quadratic equation. The thing that we need to do is to set our equation equal to 0, right? So we subtract 8y's on both sides and add 25 on both sides. We're supposed to get, what's the answer? Yes, very good. So that's what we did. And now all we have to do is solve for y. So y can be, remember what two numbers that multiply together to give you negative 40 and add to give you negative 3y? That's 8 and 5. And we have to keep the negative. So y is equivalent to negative 8. And y is positive 5. Now, of course, the rule says one of them can be extraneous because they said that you cannot take the log of a negative number. Like, for example, remember we have 2 raised to negative 1, negative 2 raised to the 1 power is equivalent to negative 2. Log base negative 2. Of course, you can't make your bases negative, neither your answer. So therefore, we're not supposed to have any negatives in logs. So therefore, y plus 5 cannot be the solution. So this can't be done. So this one cancel out. So let's try 8. Is 8 a valid solution? Let's plug it back to our equation and find out. So 8 squared is 64. Right? 5 times 8 is 40. That's 104. Plus 15 is 119. So on the left side, you have log base 10 of 119. Right? On the right hand side, this is 40 minus 25. That becomes log base 40 minus 25 is 15. Hey, wait a minute. 8 is not a possible solution either. That's not right. So therefore, in this item, there is no solution involved. Both of them are extraneous. And even though you get the positive one, it is extraneous. So you can't even do anything about that. So forget that number. Move on. Alright. Now going on to number 48. For this item, this is a very complexified equation. Although you can't see it, pero let me read it for you and I'll tell you what it is. So the first one, it says here we have log base 2 of the p plus 8 root of 1 over 32 raised to the p plus 1 power is equivalent to the p plus 8 power, the p plus 8 root of 1 half raised to the 3p minus 4 power times the p root of 2 raised to the negative 7 squared minus 4 power. This could be a bit hard to read, but let me write it for you. So let me write it for you para hindi tayo malilimutin, okay? So on the equal sign, this is the equal sign, diba? So on the equal side, we have log base 2 diba, remember this is fractional exponents. How do you write roots exponents? So therefore we change that to an exponential equation. So that's supposed to be 1 over 32 raised to the p plus 8 power. P plus 1 divided by p plus 8 power. Very good. So that's how you write the exponent, right? P minus 8. Okay? That is the one on the left. I'll write it down on our sure. And then on the second one, it is 1 half 3p minus 4 divided by p plus 8. Very good. So it's equivalent to 1 over 2 3p minus 4 p plus 8 power. Just like that. Diba? So that's on the second part. Diba? And then it's being multiplied by 2 raised to the negative 7 squared minus 4 all divided by the p power. And that's equivalent to log base 2 of 132 raised to the p plus 1 minus p minus 8 power. So that's how it's meant to be rewritten. Alright? Now let's solve for the variable. First, can you find the base? First of all, this implies the applications of the laws of exponents and the exponential equations and rational equations. The first thing that we need to do is to simplify. First, we need to find a base that is congruent within all the rest. So 1 over 32, did you find a base that's congruent? If your answer is 5, 2, you are correct. Because 2 raised to what power gives you 32? 2 raised to the 5th. So let's rewrite this again. Rewriting this, you get 2 raised to the negative 1 times 3p minus 4 power divided by p plus 8 plus, what's the second one? Just the same. 2 raised to the negative 7 squared minus 4 divided by p power. And it's equivalent to log base 2 of 2 raised to the negative 5th. Very good. Bakit negative 5th? Because 2 raised to the 5th power is 32. But negative 5th is 1 over 32. And it's raised to the p plus 1, p minus 8 power. Very good. And take note, when we have a power law, the negative 5 can be distributed and the log base 2 of 2 are gone. And when that happens, all the bases are gone too. Right? So this implies the application of exponential equations. Right? So the log cancels, and now we're just down to rational equations, right? So log base 2 of 2 is cancelled out. Or we can just take the log base 2 of 100. Log base 2 is 1 over 32, and that's supposed to be negative 5. So negative 5 times this one, right? And then all the bases are cancelled. It also works the same thing, right? Now let's do the math. Negative 1 times 3p minus 4, p plus 8, plus, remember this is addition of exponents. So negative 7 squared minus 4 divided by p is equivalent to negative 5 p plus 1 over p minus 8. Right? Am I right? Oh yeah, that's p plus 8 pala. P plus 8 pala to. Now, let's apply the math. Let's distribute. So negative 1 over 1, remember, we multiply the numerators and the denominators. Negative 1 times the binomial 3p minus 4 is equivalent to negative 1 times negative 3 is negative 3p. Negative 1 times negative 4 is positive 4. Very good. On the denominator, positive 1 times p is still p, all by itself. And plus 8, just copy your denominator. Negative 7 cubed is 49. You have a negative base, right? So 49 minus 4 is 45. And 45 over p. And that's equivalent to negative 5 times p plus 1 binomial. Negative 5 times p is negative 5p. Right? Negative 5 times positive 1 is negative 5. Right? P minus 8. Now, we're back to solving rational equations. First of all, let's identify what the LCD is. What is the LCD? That's the question. And the LCD is, if your answer is p times p plus 8, you are correct. So that's our LCD. Our LCD is this. This is our LCD. Now, we multiply everything by the LCD. This is what we get, diba? Can you follow? It will go like this. The negative 3p plus 4 over p plus 8. Plus, on the second hand, we have is equivalent to, on the right side, we have that's it, right? We multiply everything by the LCD, which is p plus 8. Right? Now, whatever we can cancel it out. Like this one, we have p plus 8 here, and this p plus 8, they're canceled. On the second hand, the p is canceled. On the right side, what can we cancel? The p plus 8. Very good. Now, we just have to multiply. So, we have this 3p plus 4 multiplied by p. Right? That's on the left side, the first term. On the second term, we have 45p plus 8. Right? And on the equal sign, we have p times negative 5p times minus 5. Very good. Now we apply the multiplication. P times negative 3p is negative 3p squared. Oh, sorry. Negative 3p squared. The first term is color black. P times 4 is 4p. Next, on the middle, 45 times p is 45p. Right? Then 45 times 8 is 360. Why? Because 45 times 2 is 90. 90 times 4 equals 360. If you were to divide that, you know that 45 times 8 is 40. 8 times 4 is 36. That's the answer, right? You can just multiply that by 2 and this will give you 90. Divide that by 2 to give you 4. 360 din. Right? So P plus 360. And it's equivalent to negative 5p squared minus 5p. Very good. Now, we need to set this equal to 0 since it's a quadratic equation. But how do we do that? We need to even this out. So we add it to both sides. So first we combine like terms here. And this should be negative 3p squared plus 49p plus 360. It's equivalent to this negative 5p something minus 5p. Then we add. So we add 5p squared here and add it to the other side. And then we add 5p here, then add it to the other side. This thing cancels, and now we're just left with 2p squared plus 54 plus 360 equals 0. Very good. Hey, this is kind of sus. You know why? Because we can factor out these numbers. So what do you think is the LCD? Or the GCF? It's 2. So we divide by 2, p squared. 54 becomes 27. 360 becomes 180. So let's do it here. So p squared plus 27 plus 180 equals 0. And all of this being multiplied by 2. Dividing by 2, the 2's cancel. Now we play the factoring game. What two numbers that you can multiply together to give you positive 180 and then add to give you 27? What do you think the answer is? 15 and 12. Let's see. 15 times 12, 10, 30, 15, 180. Correct. So 12 and 15. Add this together. 12 times 15 to give you, remember doing this method again. Let's do this. I think we ran out of space, so let's do it on the back. So if I remember, you have p plus 12, p plus 15. This becomes 180, 15p, 12p, p squared. Then we add p squared plus 27p plus 180. It checks out. Correct. That's the right answer. Alright? Now, going back to this equation here, what do you think is the answer? P can be equivalent to negative 12 or P can be equivalent to negative 15. Either of the two will work. But let's check. Let's check our solutions. Don't celebrate yet. So going back to our original equation, which is this log stop, we have P is negative 12. Let's try to the calculator para mas mabilis. So get your calculators ready and then let's solve for the answer. So diba yung memory sabi ko dito, we have here log base 2, diba log base x, put any number you like, log base 2, diba? Log base 2 of, what's the answer that we get? 1 over 32. 32 that's being raised to the, what is the base? It's being raised to the it's raised to the fraction of negative 12, negative 12, plus 1 all divided by negative 12 plus 8. Do you know the answer that we're supposed to get is nan? Bakit nan? Because it's infinite. So therefore, negative 12 is not a valid answer. Because if I remember, we get the root, ganito kasi yun. If I remember, log base 2 of 132 is negative 5, right? So let's do it without the fraction first. Negative 5. And negative 5 raised to the negative 12 minus plus 1, negative 12 plus 8. Tama, we are supposed to be getting that power of negative 83.59 something. So put that in your head. Or let me write it down para hindi tayo malilimutin. So the answer that we get is negative 83.59253.812. Okay? That's the answer that we're supposed to get. Let's try it with the original equation. So in the original equation we have, it's equivalent to then root of p plus 8, negative 12 plus 8 is negative 4, right? It's equivalent to 1/2. Raised to the 3 times negative 12 minus 4 power times, again we put this radical, negative 12 here, we're taking the negative 12 root of 2 raised to the 49 minus 4 power. Let's see if we got it right. This seems like a strange answer. Although it's not the right answer that we expected, it may seem kind of strange. But never mind, I think this might be a bit of extraneous because we get negative roots. And I'm afraid if we have negative roots, this will make the value so extraneous. How about let's try negative 15 naman? Kasi dito remember we got negative 15, di ba? So negative 15. Wait a sec. Was that supposed to be yeah, tama, that was supposed to be negative. Because dito ba remember, positive times positive gives you positive. Negative times negative gives you negative. Kasi dito ba remember, the answer that we're supposed to get is positive 27. So hindi pwede siya maging negative. So tama, positive. So therefore, we use negative values. So negative 15, tapos negative 15 tayo. That's the answer that we get. And it may seem kind of strange. The answer that we got is 0.0129888. So this is very time consuming. And now if we were to take the log base 2, let's do log base 2 of the answer. The log base 2 of 132, that's equivalent to negative 5. And then whatever answer you get here, it's raised to this exponent. It's raised to the negative 15 minus yeah, we may get an extraneous answer. So both of these answers are worth it when it comes to solving rational equations. However, we did not get to seem to have the right answer. So therefore, both of these answers are called extraneous. Although they were the right answers to the rational equation, but when we put them back to our exponential equation, they may not seem like the right answer. So they're called extraneous. Unless I ask a mathematician to help me solve this problem, and this will make life easier. Anyway, without any further ado, let's move on to the next problem. Now we have item 5-9. This one's tougher to solve. It says here, we have log base 7 of 20m plus 3 plus log base 7 of 1 over 3m minus 2 is equivalent to log base 7 of m minus n. Wow, that's kind of tricky. And this time, there are logs in every equation. So what do we do to the logs? And look at this. Did you know if we see here, This is the sum of the two logs. Do you know the sum of the two logs can be can apply the application of the product law? So therefore, you can just add the two logs together to simplify it into one log. That's why in this situation, we are going to play a game called simplifying logarithmic expressions, so that we can solve for each logarithmic equation. So now let's work this out. So when we apply product law of logarithms, like for example, do we remember the product law of logs is this. Like for example, if we have log AB, that's equivalent to log A log B. Just like that. That's how you expand logs. Right? But in this situation, we have log. But if you were to reverse this, you get the two arguments together, write it as one single log, and then because it's product law, we add. So that's it, right? They are the same. But in this situation, we have log base 7 log base 7 of 20m plus 3 plus log base 7 of 1 over 3m minus 2. What do? We can condense this log. How do you condense the log? Write it as one single logarithmic equation, and that's log, and since this is addition, so we do 20m plus 3 on the numerator over 1, and then we multiply that by 1 over, let me write that here para hindi kayo manilimutin, over 1. So we write log here. So multiply that with 1 over 3m minus 2. Right? So that's the answer. Pero did you know that we can also rewrite this as log 20m plus 3 divided by 3m minus 2. Can that be done? Yes, it can be. Why? This times this gives you itself. This times this gives you itself then. Combining it together, finding the product of the two, will give you this answer. Kaya that's the proper answer in logs. Okay? It's log base 7 pala. Because we have the same base. Kung different yung base, you cannot apply this law. This can only be applied if your bases are identical. That's it. Now, going back to the equation. No more shouting. So now let's go to log base 7 of this equation. 20m plus 3, 3m minus 2 is equivalent to log base 7 of m minus 10. Now we have comparison of logs. So what we do now to the logs, if they're in comparison, we can eliminate them. And then this can be written as this product. 20m plus 3 divided by 3m minus 2 equals the m minus 10 over 1. Now we can play the game called LCD if we want to, but I think it would be more convenient if we apply cross multiplication. So applying cross multiplication, we have this 20m plus 3 on the left side, and that's equivalent to 3m minus 2 times m minus 10. Let's do the equation here so that hindi tayo manilimutin. So that becomes positive 20 on the right side, and then this becomes negative 30. Negative 2m, and that becomes 3m squared, right? 20, negative 32m, and 3m squared. Okay? So therefore, that's our answer. 3m squared minus 32m plus 20. Now, we can set it equal to 0 since we know that this can be factored into quadratics. So subtracting both sides by 20m, and then subtracting both sides by 3. So what do we get? 3m squared minus 52m. Be sure to be very careful with your signs. and then plus 17 equals 0. Now we're back to quadratic equations 101. Now back to the cross. To do the cross, remember, now our A is not equivalent to 1. So what do we do? A times C, or AC Bonifacio to give you 51. Diba? Positive 51. And then, what two numbers that you can multiply together to give you 51, and then add to give you negative 52? What are they? 51 and 1. Right. But one of them must be negative. And that is, because the answer is positive. Therefore, both of them should have the same signs. Because multiplying both signs all together yields you positive, right? Multiplying different signs will give you negative. So therefore, negative 151 and negative 1. Now, going to this one. We have here this thing, right? The parenthesis. Equals 0. M. So we know that 3m times m gives you 3m. So therefore, we got 51 on the other side. And 51 divided by 3 gives you 17. And then we have 1 here. So therefore, what's the sign? Negative. Double check. Double check again. (3m minus 1), m minus 17. Positive 17. Negative 51m. Negative 1m. 3m squared. 3m squared minus 52m. Plus 17. Correct. That's the answer. So therefore, what are the values of m? The possible values of m are m, 3m, minus 1 equals 0. Add 1 to both sides. You get 3m is equivalent to 1. Divide both sides by 3. So m is equivalent to 1/3, which is one of the answers here. 1/3 can be a valid solution in the situation. Or m is equivalent to positive 17. Now let's double check using the calculator. First, let's do 17. Going back to our equation here, we have this equation. Let me write that down for you again. Give me time to write it down. So yan, you have log base 7 of 17, 20 times 17. 20 times 17 equals 340 minus 3. That's 3, diba? Plus log base 7 of 1 over 3 times 17 minus 2 is equivalent to log base 7 of 17 minus 10. We multiply these numbers together and we get log base 7 of 343, diba? Plus 3 times log base 7 of 1 over 51 minus 2 to give you 49. 49 to and then that's equivalent to log base 7 of 7. Now we simplify the logs. Log base 7 of 343, we can translate that to an exponential equation. 7 raised to 1 power gives you 343, and that's 3. So ito yung 3. 3. And then this one, 49. So that's 49 is 7 squared. So that's negative 2. Negative 2. Right? And then log base 10 over 7 is just 1. And 3 minus 2 is just 1. So this checks. Correct. So 17 is a valid solution. On the other hand, if we have 3, 1/3, 20 times 1/3 plus 3, do you remember 20 times 1/3 plus 3? That becomes 6 and 1/3. 6 and 1/3 plus 3 equals 9 and 1/3. So it becomes log base 7 of 9 and 1/3. Right? Ay, wait! That's 20 times 6 and 1/3 pala. 20 times, ano yun? 20 times 1 over 3. Because 20 times 1 equals 20. And 20, and then 1 times 3 is just 3. So that's 20 over 3. So 20 over 3m. 20 over 3 plus 3. Or you can apply LCD. Applying the LCD, this is 3 over 1. This becomes 9 over 3. Right? So this becomes 29 over 3. So log base 7 of 7, 9 and 1/3. Tama, it's the same. 9 and 1/3. And then, di ba remember on the bottom, we have 1 over 3 times m minus 2. 3 times 1/3 is the same as dividing it out. So therefore, it becomes 3. And therefore, 1 minus 2 is negative 1. 1 divided by negative 1 is equivalent to plus log base 7 of negative 1. Wait! That can't be done! Because look! Do I remember what did I tell you in our definition of logs? We cannot take the log of a negative number! So therefore, that 1/3 is an extraneous solution! That's an extraneous solution yet again. And then we have 1/3 minus 10. Yes, that can't be done then, because yet that still yields to a negative solution, a negative value of logs. And if we were to try, you might remember 1/3 is the same as 0.3333 and a bunch of 3's. Minus 10, or 10 minus 0.3333, we get negative 66669.66666 and a bunch of 6's. So that can't be done. So therefore, having 1/3 in our solution, that is extraneous. So we can't use that. We can't use 1/3. If m were equivalent to 1/3, therefore this value is what you call extraneous. Extraneous solution. So this can't be done. So hindi pwede tayo gumamit ng 1/3 dahil extraneous ang solution na to. And even if we were to plug it into the calculator, that can't be done. So yan.